Hello everyone. Today in this video, I'll be discussing the module 5 of SS. So in module 5 of SS, we mainly have three topics. So first we'll be going through the syllabus, and then we'll be seeing what all you need to focus from each of these topics. Okay, and what are these topics mean, and where you need to focus upon in these topics. Everything we'll be discussing in this video. Okay. So before starting this video, if you like this video, hit the like button and don't forget to subscribe to my channel. Okay, so let's get started. So module 5 has how many topics? Three topics. Okay, so those three topics are syntax directed translation, intermediate code generation, and code generation. Okay, so these are the three units which this module 5 has. Now our task is to learn these three modules and see what are the important things in it. So let's dive into each of these topic and see what is in it. Okay, so what are the topics under each? Questions repeatedly asked under each topic, important concepts topic wise which you need to keep in mind. Okay, so if you study what are the topics I tell you to study from these three topics, then that will be sufficient for you. Okay, so in the first topic, syntax directed translation. Okay, so what is there in the first topic is you need to know the difference between synthesized and inherited attributes. See, for whatever concept we consider, for that concept we have in some we have the subparts, right? In syntax directed translation or SDD, in syntax directed definition, in that we have two parts, which is synthesized and inherited. These are the two types, and synthesized is of S type. Okay, remember, synthesized is of S type and inherited is of L type. Okay, so the more important one is synthesized, and this is far more easier as well, and from the exam point of view more questions are asked from synthesized. So in this video I'm just going to explain what is S of SDD, because I couldn't find any question in the previous paper which was regarding L of SDD and inherited ones. Okay, so I'll be just explaining this one, and that would cover like 80 to 90% of the module. Okay, so first you need to know what is SDD, the definition of it, and what is synthesized and inherited attributes, just the definition of it. Okay, then we will be diving deep into synthesized. In synthesized we have two types, which is SDD. These are the two types, which is inherited known as L-SDD, synthesized known as SDD. And inside SDD we will get the numericals as well. So in that numericals it's important: protection rules, semantic rules, annotated parse tree, dependency graph, and topological sorting. So these things you need to know how to write for the given S of SDD. Expression will be given, you have to write these things, and we'll be discussing one example question for it. Okay, then we have the third topic, which is the difference between S of SDD and L of SDD. What is the difference? For a quick point, what I'll tell you is the difference is that in L you will have no left recursion. Okay, there will be no left recursion in L of SDD. That's all. Here electrification might be there, might not be there, but here pakka it will not be there. That's the key difference between SDD and LSDD. Moving on, we have the intermediate code generation, which is the second topic. Okay, in the intermediate code generation we need to know about the DAG means directed acyclic graph. Along with the steps you have to write, and the means for the expression which they give, you have to make a directed acyclic graph, and we have to mention the steps as well. So we'll be discussing an example for it. Then we have the second topic, which is three address code, quadruple, triples, indirect triples, and static single assignment. The last one is means the least repeated one. So the important one is these four. So we'll be discussing an example and seeing how to write each of these. Okay. Then we have the third chapter, which is about the code generation. So here are some theoretical topics, like for example, you need to know about the issues in code generation. So issues in code generation, there are 5 points, and you have to remember it in this way: ITIRE. Okay, just say it from your mouth: ITIRE. Remember like that only, ITIRE. Okay, I'll be telling its full form later. Generate the instruction code for the three address code. This is one problem type, and this is another problem type: program instruction cost. Okay, that's all what is there in the module 5. It's more than enough if you do these topics very thoroughly, because 80 to 90% of the questions come from these topics only. So let's get started with the first topic, which is you need to know the difference between synthesized and inherited attribute. So what do you need to write in exam if they ask the difference is? Start from here. These notes are available in the description link. You can go through it and download these notes. Okay, so this is the first chapter, which is syntax directed translation. Okay, so this is the first chapter, syntax directed translation, and it has 4 topics. So no need to worry about this. I'll tell you what all you need to focus. So what I have told to focus is this first question. You need to know the difference between synthesized and inherited attribute. So what is synthesized and what is inherited? Basically, syntax directed translation, or SDD. It is divided into 2 parts, which is synthesized attributes and inherited attributes. So what is synthesized and what is inherited? Synthesized means parent to child. Just remember this keyword. Note it down somewhere. Synthesized means parent to child. Inherited means siblings also are involved. So parent to child means in synthesize what will happen, n is the node and c is the child. So synthesize means child to parent or parent to child, and here also parent to child, and here by itself. These are the 3 categories or the 3 cases in synthesized. In inherited, what you have is you can go from sibling to sibling also. Sibling to sibling also and parent to child also. Both are possible. In the first one, only one is possible. In this, both are possible. So that's what the difference between synthesized and inherited attribute. So an example you can give of this one, and for the theory part you can go through it. The same what I told you, that's only written like from parent to child, and from sibling to sibling is also possible. That's the difference between synthesized and inherited attribute. Okay, then the next question what I told you to focus upon is this one. Under the syntax directive, there are 2 types of SDD, S-SDD and L-SDD. So you need to know the difference between them, right? So this is S-SDD. It will not have left recursion. It will have not. It will have left recursion, and L-SDD will not have left recursion. So in that subtopics come like annotated parse tree, production, semantic rules. This will be same for all of the questions under S-SDD. Okay, and this is L-SDD. This is the production semantic rules, slightly differed, and here you don't have left recursion, and one of them is top down, which is left L-SDD, and bottom up is SDD. Okay, then evaluation order, this is topological sorting, this topic. Okay, the last topic, topological sorting, is nothing but the evaluation they are talking about. And annotated parse also is shown. Dependency graph is the fourth topic. So here is the dependency graph. So all the topics which you are need to focus upon are that I have mentioned. Okay, so by using an example you will be understanding how to solve the question under this topic. Okay, so if you are able to solve the question under this topic, like you need to if you know the difference between synthesized and inherited, difference between S-SDD and L-SDD, and you can solve this question, then you can means you are good to go with the first chapter. Means you are ready to answer any question from first chapter, because most questions come from these topics only. Okay. So how to solve a question from this topic? Let's take a most repeated topic. This is the very repeated question, which is write a SDD for simple desk calculation. So first thing in this type of question, SDD, if they give you, you have to take SSDD. Okay, don't take LSDD, take SDD. Okay, so here the question will be as follows. What is your input you are given with? Input is 3 into 5 plus 4n. This is the thing which you are given with. So your first step is to write the production and the semantic rules. I already mentioned here this sequence you need to remember. Production and semantic rules, then these 3. Production and semantic rules, then these 3. That's how you solve SDD questions. Production will write here, semantic rules will write here. It's very simple. L goes to En. E is an expression, so it's ending with N. E is nothing but from 3 till 4, and N is just N here. And E goes to E1 plus T. This is one production, E1 plus T, or E goes to T. T goes to T1 or T1 star F or F. F goes to E or digit. This is the first program of our SS lab, right? The shift reduce parsing. There also the same productions are there. The same you have to write with the semantic rules. Just you will write L dot val is equal to E dot val. E dot val is equal to E1 dot val plus T dot val. Just put val at the right side of each of these. That will become the semantic rules. This is the difference. For digit you will not put val, you will put lex val. That's all. After you have written these two, this will be the same for all the questions. Then you have to write the annotated parse tree. That's the third step, our third step, right? Annotated parse tree. So let's see how to write annotated parse tree. If you observe carefully here, where you are starting the program from, 3 into 5. That's the first thing which you are taking into consideration. So what you will write is, first you will write here 3. 3 is a digit. 5 is also a digit. So you'll be writing 3 and 5 as such. Okay. Then you come here and see you have written a digit. Digit can go to F. F can go to T. Observe carefully whether it is plus or into after that. After 3 it is into, right? Means multiplication. So you'll go to F, and cleverly you will go to T, and then you will use this formula. You will not go to E. because you can't go here because it is plus. You need to have multiplication sign here. That's why what you will be doing is you will be using this one, then you will stop at t, or you will stop at f to make f here, then t, both you can do. Okay, so what I will choose is 3 will go to f. Just write initially digit f and t. After that add val and all those things you'll add later. First write digit f t, and this goes to means t is here, then star is here, then f is here. Digit the second digit, which is 5, and f. When you reach till f, just stop, because at that point what you have reached is t and f. So what is missing in between, that you see from here. You have reached 3 and f, means t and f, 3 and 5, and in between star is missing. So I put star here. So what will happen? You will reach t. T goes to t1 star f. Three things. It has three childs, right? So you'll write three childs. T goes to t1 star f. Repeating again. Start from here. 3 and 5 were the things. You need the multiplication sign here. Digit f t. Stop here. Then digit f. Don't go to t. Just stop here, because t into f is defined. Put a into sign here. All these three belong to the t parent node, and that will be 3 into 5, 15. You'll write 15 here. Then you will again see what is the next thing which is happening. After 15, according to the input, you will be doing plus 4n. So this is one part plus one part. Where is that defined? Here. One part plus one part. Now you are present at this part, right? So here what you are doing is e plus t. That's what you are doing here, e plus t. So t will become e first, because you have reached this point here. This is t here, but it is e plus t. So you can't write t plus t here. So t should be converted to e. Then you will write e plus t. So how to convert t to e is just a direct thing is given here. Direct conversion, t goes to e. So you will be writing here t goes to e, then plus, then again you will write t, and the t goes to f, f goes to digit, because what you need is 4. The next thing here is 4, right? 4. So this is t, this is e. So this will become e plus t. Then you are remaining with n. What you will do is you will take this as e, and then you just need n here. So where is that defined? E is here, n is here. Both are defined from L. So L you will define here. You will keep it as e here and n here. So that's what your answer, which you get 19. 3 into 5, 15. 15 plus 4, 19. Okay, that's how you solve the SDD problems. After creating the annotated parse tree, the simple thing what you need to do is the topological sorting. For that, you need to draw dependency graph. For dependency graph, you just have to write the same thing, annotated parse tree, and write the steps. From here, what you took, 1, 2, 3. 3 steps you took, you stopped here. 4, 5, you stopped here. After you have stopped at these 4 steps, these 4 combined to form 6. Then again 7, you stopped here. 8, 9, 10, you stopped here. Added these both and wrote here as 11, means 11 step. Then gone to 12. Then we'll write the fifth step, which is the topological sorting. 1 2 3 4 5 6 7 8 9 10 11 12. 1 2 3 4 5 6, then 7 8 9 10 11 12. Okay, so these are the things which you need to do in the exam as well. Okay, so this one they have taken as step 1. I took step 1, step 2, that's why I told step 5 at the last. But that's how you solve any of the SDD problems, and this is one of the most repeated ones. Okay, so you can go through it. Many questions are there. If you got some doubt, you can ask me. Make sure you solve the SDD ones only. Don't solve this ones. It means yeah, this is also SDD. Don't solve LSDD. In LSDD, you will have a different type of production. Okay. In question also they will mention write a L attributed SDD. This one you skip because it's very less repeated in exam. So you can focus more on SDD. Okay. So many questions are there. You can solve this. Then we have the difference between SDD and LSDD. This is present in page number 7. If you want to note down, you can note it down somewhere. Like if you go to page 7, you'll get to know here the difference. You can go to the theoretical concepts. This is the difference between LSDD and SSDD. S attributed definition and L attributed definition. You will go through it and write down the answer if they ask in exam. Okay. So basically, yeah, that's all what is there 80 to 90% in the first chapter. Let's move on to the second chapter, which is intermediate code generation. For that, the first thing which you need to know is the DAG, which is the short form of directed acyclic graph. So let's go to the DAG part. Okay, so that is present in which page? 57. So 57 is this one. Let's see, it's I guess 37. Yeah, In 37 page you will get this one, directed acyclic graph. You have to learn this one. Okay, so here what we have is this expression is given to us. We have to write a DAG for it. So what is a DAG? Let's start from the simple problems and move to the harder one. So let's draw the DAG for simple ones. So yeah, here is the DAG for simple ones. So see, this is the expression given to us, a plus b plus a plus b. So in DAG, the first step what you need to remember is you have to solve the bracket part first. So in bracket part, what you have written, a plus b. So a you will write here. What are the means the variables which you use, that you will be writing first, or even you can write this thing first. What you have to see is how many unique terminals are there. A is a unique terminal and B is also a unique terminal. So you'll write 1 ID A, 2 ID B. After you have written this one and this one, the IDs are assigned as 1 and 2 for A and B respectively. Then what you have is A plus B. If you substitute with the IDs, it will be 1 plus 2 and that will be stored somewhere. So that's what we are doing here in 3 plus 1 2. So this is 1 plus 2 and that is stored in 3. So what does 3 denote? 3 denotes the sum of this, right? Again what we have here, b plus a. Again we can use just 3 instead of b plus a separately, because this is already defined in 3. So I'll substitute here 3 plus 3. So that's what I've written here, 3 plus 3. Repeating again, first step what you need to do is find out how many terminals are there. Note down the terminals as 1 id a, 2 id b, and then see what is in the brackets. In the brackets what you have is a plus b. If you assign the IDs, it will be 1 plus 2. Assign it to 3. So what is 3? 1 plus 2, which is nothing but a plus b. This part is done. This is known as 3. And if you observe carefully, this part is also 3. So what you will write is 3 plus 3. That will store in 4 plus 3 3, which is 3 plus 3. And after making this one, how to make this one is very simple. What are the IDs you can find? Put in the bottom part. So A and B, you have put the IDs. Then what is the third thing here? Third thing is 1 and 2, it is getting plus, right? 1 and 2 is getting plus. So this is 1, this is 2, and that is getting plus. So 1 2. And what will this become? This will become 3. So put it as 3 here. Next, what is happening in 4? Plus is happening with 3 and 3. So what is happening with 4? Plus is happening, and this is 4, and from where it is happening? From 3 and 3. So this is 3 from 3 and 3. So what will happen? A plus b will be stored here. That will be taken as a plus b plus again a plus b. So that's what we need, a plus b plus a plus b. This is how we make the directed acyclic graph. Let's discuss few more examples to make the concept more clear for you. So a plus b, again a plus b. This you can do it separately as well. So if you do it separately, note down what are the unique symbols, a and b, id id. After that what you have, 1 plus 2, that will be stored in 3, 1 plus 2. Then for 3 what you are adding, again a you are adding. A is defined in 1. So 3 plus 1, 3 plus 1, that is stored in 4. So till this part it is 4, 4 plus, where is b defined? 2. So 4 plus 2 you will be writing in 5. 4 plus 2. So this is how you make the table. How to make the graph is, first write the unique things in the bottom. A and B you have written in the bottom. Next, what is the step? You define plus and connect 1 and 2. This is 1, this is 2. Define a plus, connect 1 and 2 and mark it as 3. So this is 3 here. Next step is 3 and 1, make a plus, connect 3 and 1, mark it as 4. Make a plus, connect 3 and 4. This is 3 and 1. So 3 and 1 is where? This one. So 1 is connected in this way. So 3 and 1, this is 4 here. Then what we have? 4 and 2 plus. So 4 is this one and 2 is this one. So 4, see 4 is coming like this and 2 is coming like this. That is coming here and that will be named as 5. Okay. Moving on, we have this one. Here also we will be doing the same thing. A is there, right? So ID will be writing A. Only A is the unique terminal, only one ID will be there, A. And here we have another A. So what's happening? 1 plus 1. So 1 plus 1, that is getting stored in 2. Then here another A we have, 3 A's. So this can be written as 2 plus A, which is 2 plus 1. 2 plus 1, 3. So this is defined as 3, this is defined as 2. Same thing here, this is defined as 4. Next what we are doing? 4 plus 3. 4 plus 3. When you get 4 plus 3 as 5, 5 plus 2. This is defined as 2. So 5 plus 2, that will be in 6. Here also you have to do the same thing. We can easily trace what's happening as I explained for the previous ones. Okay, that's how you draw the DAG. Now let's discuss an external example. Okay, so here's another example for DAG expression. Here what we have, observe carefully. The common terms you observe, x plus y into x minus y, x plus y into x minus y. First solve which is in the innermost bracket. I guess this is the in the innermost bracket, so we'll solve this one first. Before that, you have to write what are the unique IDs, x and y. So right here x and y, plus is here, so write it plus, minus is here. The two unique things getting used, minus is here, you will define minus. After that, x plus y, x minus y, both are getting multiplied. So put a multiply here. This is x plus y, this is x minus y, both are getting multiplied and stored here. After multiplying and storing here, what you are doing? Minus with what? X plus y, right? So x plus y, where you will get? X plus y I'll get here. This is x plus y minus this answer. This answer is what? This one. X plus y into x minus y. So here will be x plus y minus x plus y into x minus y. And that answer is stored here. This part is nothing but till here. This part is stored. And in here, what is stored is this one. X plus y into x minus y, because here what we got, x plus y, x minus y, that is stored here, and then you'll be adding both of these. Here this part you'll be adding, and here this part you'll be adding. Okay, so that's how you solve the DAC problem. Okay, let's discuss one more. So if you are able to solve this one, and these are the steps what you have tried. Okay, I'll explain what you have tried and how is this getting stored here. So see here, this is the question, previous year question. So for this what we have, the innermost bracket you have to solve b minus c. B minus c, that is getting multiplied with a. So b minus c multiplied a. After that a is getting added. Again a is getting added with what? This one, a into b minus c. Here you have a into b minus c. A is getting added. So a and b minus c. And you have d here, right? So d is getting multiplied with this one. And here what we have, b minus c, right? Till this part you understood, right? This part denotes which part? Till here. Okay, and this part b minus c into d denotes, b minus c into d denotes this part. B minus c is taken here and d is taken here, b minus c into d, and then we have plus in between connecting these both. So we'll write a plus here and connect this part and this part. Okay, so that's how you would write the DAC, and remember these ones to write the steps as well. So it's very simple. E is equal to e1 plus t. So wherever you have in the LHS part, you just write node there, dot node, and here new node. Here all new nodes, if you take new nodes, if it's the old node, you'll don't write anything. New node plus even node, t node. What you're doing plus, from which you're doing e1 and t1. E1 and t1 what you're doing plus. So you'll write new node plus e and t. Here you have minus, okay, and e1 and t. So what you're doing is the subtraction part between these both. Then you have t here, okay, and t is getting stored in e, and this is in between the brackets, so you'll just take the value here, and the leaf nodes is id. Okay, so id comma id dot entry, and here you have num, so you'll be writing num is equal to num dot val. So that's how you solve the DAG, and to write the steps you'll do the same thing here. Okay, p1 as leaf. See what is p1? P1 is the outermost thing. So outermost thing is this one, so I'll take this as p1, this I'll take this as p2. So p1 and p2 what I'm doing, minus. So how we'll write the steps is, p1 is a leaf node, p2 is also a leaf node. So I'll write p1 p2, and the values I'll enter as a, and here I'll enter as b. So actually it should be b, I guess, but anyways, after entering that one, what you're doing is node minus p3 p4, two leaves which you have taken, that what you're doing minus, and that will be stored in p5. Okay, so that's all what most can be asked in the DAG, the tree means the directed acyclic graph along with the steps. Okay, moving on, we have the next topic in the second chapter, which is 3 address code, quadruple, triples, indirect triples, and static style assignment. So we'll be discussing one example in this and moving forward. Okay, so let's see where is that example. Okay, so here's an example where you have the triples, quadruples, indirect triples, three address code, and syntax tree as well. Okay, so in the 3 address code you'll have 3 codes here. This is the 3 address code, so we'll be discussing this later. First let's see how to draw a syntax tree. Here you have b plus c, so we'll be writing b plus and c, and then you have a minus here, so we'll be writing minus, and then this is one term and this is one term connected by plus, so we'll be writing plus here, plus, and this term here. So this is how you draw a syntax tree. After that, take it as b plus c as t1, and minus is t2 is equal to minus t1, and t3 is a plus t2. A plus this is whole is t2, so a plus t2 will be assigned to t3. So this is how you draw a syntax tree and 3 address code. So let's confirm what is the 3 address code. It is looking like this. Okay, in 3 address code you will have one result here, equal to sign, and 2 operands and 1 operator. So this is how you write 3 address code. And I mean, convert it into static single assignment form. Just the difference is p is equal to a plus b. If you use again p, you have to change the p name. So it is p1 minus c here. If you use p again here, you'll write p in the 3 address code, but here you'll write p2 as separate one. Okay, and q is here. Again you use q, so you'll be writing here q1. Then you'll be writing here q2 if you use the second time here. Okay, so again if you use p, it will be p3, and the same p3 is just getting used here, so it is p3 only. Here also q1 only, here also q only, and p1 also here. If you are assigning it to some other value like p1 is equal to p2 is equal to, at that time the number will be changing. If you are just using that value, don't change the number, means the name. Okay, that's how the 3 address code and static single assignment is. And let's see how to do the quadruple. In quadruple, remember this op arg1 arg2 and result. In triples there will be no result, just op arg1 and arg2. Okay, and as you can see here, bc is there. These are the argument 1, argument 2. What is this happening? Plus is happening, so in op you'll write plus, and here it is minus. What is minus? This whole thing is result as t1. This whole result is t1, so here t1 minus, so one argument is t1 and you will have minus, and this whole is t2, so t2 and plus and a, so a and t2. Here you should have plus here. Okay, and that result is assigned to t3. Here's a mistake, it should be plus here. Same thing for triples as well, but you'll just remove the result and you'll use 0 1 2 instead of t1 t2 t3. Where you will find t1, substitute as 0, so here it will be 0. Where you find t2, substitute as 1, so here you'll find 1. So that's what 0 1, rest all the things are same. That's how the triples is. And coming to indirect triples, same thing, you copy paste here, just write 0 1 2, some address numbers here in the same order, 0 1 and 2 you'll be writing here. That's all how the indirect triples work. Okay, so that's what is there in the second chapter. So okay, that's all what can be asked mostly in the second chapter. Let's move on to the third chapter, which is our last chapter, code generation. Here you need to know a theoretical concept, which is issues in code generation, and you have to remember ITIRE. So that's just the initials of the thing which you're going to remember. So let's move to that part. So here a few more questions. You can practice these questions. Okay, so coming to the code generation, issues in the code generation, these 5 topics: ITIRE, input, I for input, T for target, I for instruction, R for register, and E for evaluation. Okay, so if you go through that topics, you'll get to know what it is. So I'm not discussing the issues in the design of code generator. It's very simple one. Okay, easily you can remember. So let's move on to the problem type, which is the instruction code generation as well as instruction cost. Okay, so we'll be done with module 5. So let's move on to the instruction code generation. You'll be discussing few. Okay, so here's the generation of instruction code. Okay, so let's see, for x is equal to y minus z, how you have to write. See, x is equal to y minus z. For y you need a register, right? Right, to store y you need a register, so r1 is equal to y, load into r1 y, like this you have to write. Okay, then for z also you need a register, so load into r2 z, so load into r2 z. Then what you are doing, minus we are doing, right? So r1 plus r2, actually it is minus, so either we have to do the subtraction. It's not actually addition, there is a mistake here. So sub r1 and r2, so r1 is equal to r1 minus r2. Then we are storing that value in x, so st in x what, r1, like that we'll do. This is how you solve the instructions. And here a few more questions, you can go through it. And then after that we have the program instruction cost. Okay, program instruction cost. So if you're just loading from register to register, cost is equal to 1. loading from the m, which is some other variable, to the location. At that time the cost is 2. If you are loading from a pointer value indirect reference, then it will be 3 cost, and some additional costs are given here. Can go through it. Okay, then what we have is the cost of each statement 1 plus cost of addressing mode. The cost of addressing mode is given based on this 1 plus that value. Okay, so let's see one example. Here we have the cost of the following instruction, R naught and Y. Y is nothing but memory location. So for memory location, it is one cost. From memory to R naught, it is one, and one you have to add as usual. So it will be two here. For this also, it is two, and for this, it is just from the register to register, it is zero, and then you are doing add, so it will be one plus zero because R to R is zero only, as you can see here. If you're doing from R to R, then it will be 0. R to R means 0. Okay, and for addition it is 1, so you'll be doing 1 plus, so you will have 1. And storing from R naught to this one, so it is from register to memory or memory to register, both the cases you will do 1. Okay, and 1 plus 1, it is 2. Total cost is 7. Okay, so here's few more questions, we can go through it, but the concept remains same. So that's all for the module 5, and make sure you hit the like button and don't forget to subscribe to my channel, and thank you so much for watching. I'll see you in the next one.